David, thanks for sending those papers. And I do agree with you on pH and alkalinity. The only
Mm.
thing that I actually have a problem with is what I'm running into with the public stuff about alkaline diet. And
Yeah, they just need to be educated because a lot of misinformation by Robert O. Young was put into the marketplace. That's the alkalize or die, right? The um, critical mass of the research is not just there. I am surprised that it took New Scientist until October 2025 to do an article on it.
Are you serious?
Yeah. So that with the one that I sent you is from New Scientist. That's October 1st, 2025.
Read the date.
Why this is all coming to light now is we know the mechanism, but it's only since 2015, and it's liquid-liquid phase separation. When you change the electrochemical gradient and you change the moments of hydrogen bonding potential or whatever you're doing, you're changing the ability of the biomolecular condensates in the intrinsically disordered regions of the proteins to form properly. That's it. So, and
been
every
known
acid
in food
can act as a
science.
base. We forget our basic chemistry. It's environmental. Electron donation and acceptance is an environmental condition. It is not two molecules that happen to be just like this. There's 10,000 of them. The electrochemical gradient responds to that. So
Science for canning and everything else for baby foods, that's critical to look at electrochemical potential when you're mixing for baby foods, because when you add the heat and the heat stimulation of the molecules, it can cause separation that you don't want. And it's used as a terrible excuse by some food scientists who really don't understand the principles when they add protein to those types of foods. And they use that as an excuse. And I look at them like, no, you don't have enough protein concentration in some cases. As long as your water ratio is correct to the protein, you have enough to be able to hold it. But you do need something for emulsifying the other branches of protein into the rest of whatever your configuration is and not go too acidic, because we know double folding of protein happens in too high of an acid, which is high electron intake. But even for coaching, 20 years ago, I was telling people, like, from medical science, I knew the pH gradient differentiation in your GI tract was critical to digestion just from a basic medical concept. And I used to tell people, like, you can't mess with like, yes, it's fun to do the sour ball challenges that kids used to do with eating as much of the sour stuff as possible, or how many vitamin C pills, whatever. But I said, that really messes you up over time. And people drinking too much bicarb.
How do you account? So, my understanding is that the body adjusts, through homeostasis to.
Good question, Blake. So it's nothing to do with the body's pH balance. This is the trick. It's not the body. It's the influence in the microenvironment of the gut. And if you understand what I would suggest is to look into this. I'm not suggesting you don't understand, but to look into the more nuanced understanding in the last 5 years on how mucin actually even gets put into the gut. Goblet cells so essentially what they go is they undergo a change due to biomolecular condensates and liquid-liquid phase separation that allows the tightly packed mucin to explode into the first layer of hydrogel. The first layer of hydrogel is actually stiff and it's meant to be barrier-like, but as that gradient changes and the electrochemical gradient changes and the mucin folds differently and expands into the space and attracts water and does all of these things, that's where this is playing out. And ultra-processed food is devoid of the nutrition that actually is responsible for creating the environmental conditions. Organic acids would be a great example, polyphenols, anything like that. Polyunsaturated fatty acids, which have a shape charge, anything with shape charges, and even things that are sterile charges. And what I mean by that is fully hydrogenated fats that should have a more equal shape charge. They also play a role. So you have highly reactive species and non-reactive ones, and they're changing the electrochemical gradient. Melatonin's a player here. So when you see melatonin in the gut, it actually has nothing to do with sleeping. It may have something to do with circadian modulation, but it also has something to do with melatonin's special ability to create an environment for biomolecular condensation to take place. So
Right.
it's nothing to do with body pH. That's way later on down the road when you're using the bicarb and sodium and chloride shunts and everything else where you're balancing respiratory acid and all of those other things. Totally true. But what we didn't realize is in order to maintain that balance, there's a whole bunch going on in the gut, the immune system, and the inflammatory system that allows that buffering to take place.
So which part of the gut are you talking? Are you talking about the stomach or small
everything.
intestine?
Everything.
pH gradient changes.
For example, PPIs, they affect liquid-liquid phase separation. This is brand new. So it's no surprise that people don't know this yet. I'm just learning it. But even parietal cells are under the influence of liquid-liquid phase separation. The mucus lining in the stomach is under the influence of liquid-liquid phase separation. The alkalinity in the small intestine is under influence of liquid-liquid phase separation. And then you have what are called fiber-bound polyphenols. So those polyphenols do not separate in the small intestine. They cannot be. There's nothing there to get them out. Where they come out is the large colon. So you have that, and they break off. You have the fiber component for short chain fatty acid production, and now you have the polyphenols. They're called fiber-bound polyphenols. 65 to 80% of, let's just say, whole grains, beans, legumes, they're fiber-bound polyphenols.
Sorry, that's me. I hit a
no, that's
wrong
okay.
button.
Their fiber-bound polyphenols are at 65 to 85%, whereas fruit and veg are, you can put it around 24%, 25%. But so the skin of an apple, that's fiber-bound polyphenols. So yeah, there's a lot of nutrition there, but it gets delivered to the distal colon. The fruit itself gets delivered to the small intestine. So far, that's kind of some of the nuance that we have about that. But this is exploding. One of the places exploding, I'll just throw this out there so we can talk about it. Emulsifiers. Emulsifiers are greatly damaging the environmental liquid phase separation, surfactant-like ability of the top layer of mucin, which is a little bit more fluid and liquid. It allows that it's a transition zone. When they connect there, it just creates barrier integrity problems through a dismantling of liquid-liquid phase separation. When you actually look at how zonulin and occludin work, how Z01 and occludin work, it's all LLPS.
That's interesting. So when we talk about emulsifiers, and I think about ones that are found in our food, so we go to
polysorbate 80 and carrageenan. Those are the two major ones that just come out in trials over and over and over again. They initiate dysbiosis. Now the carrageenan's interesting.
So, but let's talk about egg yolk. So egg yolk and egg whites have natural emulsifiers, phospholipids, and things like that. So why wouldn't we think that those would be having similar negative effects to?
And you're asking the big money question. And that big money question is, what is the difference between natural emulsifiers and non-natural emulsifiers? So here's one of them. This is how nuanced this gets. North American guts of non-Asian origin. So they're white, they're black, there's something else, maybe Indian, something like that. Or Southeast Asian, whatever it looks like, they may or may not have the correct amount of carrageenan degraders. But when you go to Japanese and Chinese guts that are at least Japanese, I know the data is there. Sorry, I shouldn't suggest Chinese guts have it. I know Japanese guts have it. They're at 65 to 70% of carrageenan biotransformation through their microbiome. It's environmental. It's based on the culture. It's based on the food supply. It's based on the fact that they've eaten carrageenan for a long time. And I believe the same applies for MSG. MSG is also broken down and biotransformed in the gut. Asian guts have a big MSG degrading system in them. North American guts, not so much.
From a personal standpoint, I'm going to add a couple of things here. One of the reasons that we may have more microbiome to attend to carrageenan, but I will caution, out of the different types of carrageenan, if it's closest to the natural source, we can handle it. Same thing with MSG. My mother could never have synthesized MSG. She would go into severe headaches, but she could have all of her homemade miso, all the homemade wines, all the.
So getting back to that, that's where I think egg yolks, which are a known emulsifier in cooking. If you're a cook, you absolutely have used eggs as an emulsifier at some point in your life. That's true. But as you said, that comes with a whole bunch of other nutrition.
Exactly.
And so it's very different than linear inputs into harmonic systems. Sorbate 80 is a linear input. Carrageenan is a linear input. So one of the things that the natural health product industry is going to have to come to grips with is things that have GRAS status that are not, because the way the GRAS generally regarded as safe, GRAS didn't look at the gut. GRAS looked at something else.
We
And
didn't
it's
know.
also GRAS is on the industry side. You determine GRAS status, and then you tell the government you have GRAS status. So there are some things we need to contend with here in food additives, food ingredients. You're right, Blake. There is a gray area that's a bit murky right now, but
Let me
we are
add,
getting resolution here.
we
And
do
it
have
is
another.
coming. Singular inputs do not look like they're going to be overly helpful for guts that are already distressed. That's the other part. An industrialized gut under the influence of additional emulsifiers never ends well.
Well,
No.
and you know, you bring up an interesting point too, is the individual variability of
Huge.
whether something is safe for one person versus not for the other. And it's hard to tease apart the effects of one particular ingredient when we're consuming thousands or tens of thousands in our food every day. But yes, certainly there's credence to the fact that certain ingredients we use are negatively affecting the gut microbiome. Now, you know, until we determine how we define a healthy microbiome, we're still on Firmicutes versus Bacteroides and enterotoxin producing. And it's fascinating to me to see how science is, you know, looking at mechanism, which mechanism is very important, but we have to bridge the gap from mechanism to outcome. So what is the ultimate outcome from this mechanism we talk about? But yeah, it's amazing to me to also see how AI has advanced so quickly to determine, you know, some of these things. And I saw a study published yesterday in Nature was
Chat for me, Blake. I didn't see that. I'd love to see that. That
yeah.
sounds very interesting. Yeah, definitely.
I'm going to add one other thing that's going to make things more complicated. Last week there was a study that came out from, I think it was South Africa, and it was the first metadata study or analysis of different African indigenous microbiomes. And this is something that Stanford missed because they were focused on specific groups of people at singular studies. So in the Western society, and now I have to update. There's a child that I'm tutoring right now interested in microbiome, and now I have to update this information for her. In fact, not only did the obelisk information, about 3,000 to 4,000 obelisks is what they think they have as separated items, but this new study had up to 40,000 unidentified genomes, suggesting that not the maximum of an estimated 7,000 species in our gut. We are looking at some of the indigenous African people as having up to 40,000. And then they found a whole separate singular group that was out of the HIV population with whole other sets of genomes. And so basically, again, this is giving credence to whatever the I would say, like the shamans and the curanderos and traditional medicine people had told me growing up as a child, that each body is individual ultimately. It is not one for everybody. That's why their medicine is so individually prepared. They study the individual. They study what the individual is excreting, sleeping, eating, breathing, how they're walking, how they're doing things, how they talk, how they eat, before they even start making medicine, unless they're dying. Then there's, emergency things that they do as well, like we do. But it really adds to that complexity. And one of the things that I've always noticed, because I was around a lot of immigrants, whether from Europe or whatever, from war-torn countries, from here, second generation people and other things. And in looking at all of the different foods, even growing up, I remember when I was, especially when I was young, if I took my mother's homemade foods, the kimchis and things, into school, there were people getting sick from the odor of it. And then I wasn't allowed to take my own lunch into school in some schools because they were so disgusted, right? Now, okay, the society's all for kimchi. Most places it's fine. They like the smelly stuff. But I started recognizing back then, like even my immigrant associates, or the elders anyway, and my family, they always talked about going slow with a new food introduction, like not eating too much at one time. And I think it has to do with this whole microbiome science. And when you go into into the physiochemistry aspect, which is how I do prefer to formulate. I like to think about the physiochemistry aspect of the identified primary molecular structures within the items we put together, because they matter. Like some of my career in conventional science, I was busy cleaning up, seeing if I could take the polysorbate 80 out, improving it and why. Other areas were testing novel ingredients, obviously, to put into formulations and seeing if they worked or not. And I was always looking for behavioral aspects from beginning to end. I never let somebody else formulate if possible because I wanted to see it. I think it's because of that influence I have. And like really all that physiochemical aspect, like with carrageenan, it's not just, remember, one type of carrageenan. There's multiple types of carrageenans, which the chefs had already identified. But one of the reasons I think carrageenan is so damaging when you're using it as an isolated ingredient, that has been processed to have ultimate capability of binding certain types of compounds, especially with water. It's very reactive, of course, coming from a seaweed. And historically, that means that it has the ability, almost as great as salt, to be able to water pull, not just bind, but water pull in an area. And I think that is the main reason it can be very damaging, because when you're talking about microbes, and thinking that even light can kill microbes, the tiniest bit of shift changes the electric potential, and tiniest water shifts really destroys it. The high salt diet here, that's big.
You bring up a really interesting point that I think about a lot is, the difference between the isolated compound and the bound version of it. So for example, isolated amino acids versus the protein, which contains those amino acids, and they respond very differently in the gut. Otherwise, why would we have studies on L-tyrosine and military soldiers and not just protein, right? And so there is this kind of exposure element of the molecule itself to the body and to the gut, but also the timing of how it breaks down and metabolizes, I think, is very interesting. But going back to the microbiome, I was amazed last year in 2025, the number of studies tying the microbiome to different diseases, whether it be Parkinson's or
I checked
Alzheimer's.
yesterday, Blake. So in 2022, there was 21,000. In 2023, there was 23,000. And 2025, there was 31,700 and change on a PubMed human microbiome search. That was the control
I think
term.
I go nuts because that's my favorite subject to read. And there's hundreds per day right now coming out, and trying to pick through, okay, who's accurate, which one ties in with what. I'm kind of very grateful that I stumbled onto reading the papers from 20 years ago on, because if I didn't, and I do see this happening, which is why online there's a lot of disinformation. And by no means do I consider myself an expert in the microbiome field, but I've dabbled enough that I can pick apart what I think has more validity or not, or what ties into an ongoing theory, let's say. But what I'm seeing with a lot of the newcomers in the microbiome field, whether it be coaches or people just trying to do social influencing, they are misreading because they don't have the background. It's kind of like, I hate to say this, but it's kind of like how Food Babe tears apart the food industry incorrectly for lack of having zero science. Like she even...
Yeah, but I would say that she also has a lot that she's onto. So I don't like putting everybody in one basket.
It's not fully correct or fully wrong. Everybody has something.
We're fully correct or fully wrong. This is the point. I think we need to see the amplifying mechanism for some of this stuff is social media. Fiber maxing is hot right now. Well, it should be. We have a massive fiber deficit in most westernized and developed countries that have ultra-processed food as one of their major components of their dietary strategy. Where they don't have an issue is Italy, 14% ultra-processed food, France, 13% ultra-processed food. Where they do have an issue in barrier integrity, the UK, Canada, Australia, and the United States, upwards of 60 to 70% ultra-processed food.
But
so we have a
also
rise in colorectal cancer. You have all these other things. I'll just get back to carrageenan really quick, just to tie off that loose end. Carrageenan and polysorbate 80, we know the mechanism. The mechanism is it changes the surface tension of the top layer of the hydrogel that we call mucin. That's what's happening. Salt changes the electrochemical gradient in the top layer. These things are changing the way that this, and everybody thinks mucin's mucin. Mucin's not mucin, man, or woman, people. I'm going to tell you that it is a thick, complex thing that we have no idea actually what's going on. It's loaded in serine residues, for example. It's loaded in calcium. It creates an ionic framework that allows permeability, right? So you change that, you're changing the way that you are interfacing with the outside world. So, I mean, average North American fiber intake's 13 to 15 grams.